Your eyes blow pretty much any camera system out of the water. They're incredibly good at picking up a lot of detail of things both far away and up close to you, but things can also go very wrong with your eyes. I'm going to show you exactly how eyes work using this laser demo, as well as what can go wrong with your eyes, and then show how different corrective technologies like glasses, contacts, and laser eye surgery address those errors and help you see clearly. So let's start with how your eyes are supposed to work. So if your eye is looking at something from far away, imagine that these lasers coming in are the lines of light coming in from something off in the distance. It takes in that light, and then your cornea, the very front surface of your eye, as well as the lens inside of your eye right past that, take in that light and bend it, focusing that light onto a point on your retina at the very back of your eye. If that is focused into a nice sharp point, you have very clear vision. Again, what we just showed is for looking at things far away, maybe like a star or something very far in the distance. For things much closer to you, the way that light bends is actually a little different. Here you can see that those lines come together inside of the eye, and an upside down image of what you're looking at forms on your retina, on the back of your eyes. But the setup we just showed is the easiest way to convey how your eyes are supposed to work and then how different vision errors affect that. So that's how your eyes are supposed to work, but a lot of people need glasses or contacts. So what's going wrong there? 40% of adults have nearsightedness or myopia. That means that instead of their eye forming light into a sharp point on their retina, that light is focused too soon. Their eye is actually too strong. You can see that focus point happening inside of the eye. A lot of scientists think that looking at technology a lot more when you're young is increasing the rates of myopia, so more kids are nearsighted because they're looking at phones and other things up close to their face as they're growing up. The lens in your eye changes its shape to shift your focus from things up close to you to far away from you. So if you spend more than a normal amount of time looking at things up close, like technology, your eye kind of gets stuck like that. So your eye is too used to focusing at things up close to you, which makes your eye bend light more. So if you're nearsighted like this, things up close to you are more in focus, but things further away get very blurry. So with myopia, because the light focuses too soon, on your retina, the light is no longer focused to a sharp point. You can see that those lines have spread out, and it's that spreading from a point to more of a blur that makes your vision blurry. So that's nearsightedness or myopia. The opposite of that is farsightedness or hyperopia. In that case, instead of your eye focusing light from far away into a point on your retina or focusing that light too soon, it doesn't bend the light strongly enough. Your eye would want to focus the light outside of your eye so it hits your retina before it has come to a point of focus. And again, you can see that instead of a sharp point on your retina, the lines have spread out, so there's that blur that makes your vision more blurry. And farsightedness means that things further away are more in focus while things up close to you are more blurry. There are two main types of lenses when it comes to glasses. Positive lenses, which are similar to what we've been showing so far, that take light in from far away and bend that down to a point, and negative lenses, which are the opposite. So those take in light from far away and spread that light out instead of focusing it down to a point. So if you have nearsightedness or myopia, your eyes are too strong again, focusing the light there, so you need a negative lens, meaning something that spreads light out a little bit to push that light focus back onto the retina where it's supposed to be. While if you have farsightedness, your eye is not strong enough and needs to move up the point of focus, so you need more focusing power. So another positive lens is added to bring that point of focus back onto the retina. If you look at your glasses prescription, that very first number will be SPH or spherical. If there's a positive number there, you have a positive lens, which again means that you have farsightedness and need that positive lens to move up the point of focus. If that SPH number is negative, you have a negative lens, which spreads the light out because you're nearsighted and you need to push that light back onto the retina. It's easy to understand in the sense that big numbers mean a stronger lens. The higher that number is, that means that they have more diopters. All you need to know is that more diopters means a more powerful lens. So it's bending the light more. So a positive 3 diopter lens will bend the light more sharply than a positive 2 diopter lens. But there's a third very common eye error we haven't talked about yet, astigmatism. Astigmatism is weird. It means that your eye is asymmetric. It's curved more in one direction than the other. So instead of being a sphere, it might be stretched more like an oval. So because of that asymmetric shape, your eye might focus light perfectly in one direction. Imagine that this is the vertical direction of this eye. Focuses the light right onto the retina, but in the perpendicular direction, coming out at the camera, you could be very nearsighted or farsighted. So to correct for nearsightedness, your glasses lenses also have to be curved differently in perpendicular directions. If I hold this lens closer to the camera and rotate it, you'll see that its thickness and curvature change in different directions as I rotate it. So this is a lens used to correct for astigmatism. If I hold it up in front of the lasers, as I rotate it, you'll see that how sharply it's bending the light changes. And I'm keeping it the same distance away from the lasers. If you look at your eye prescription, the cylinder or CYL number describes if you have astigmatism. Any number there means that you have it, and the greater the magnitude of that number means that the stronger your astigmatism is. And the next number on your eye prescription is axis. That describes the orientation of your astigmatism. So the eye doctor needs to know which direction of your lens is curved more. And contacts correct for your vision in the exact same way that we just showed what glasses are doing. Except because they're up close right onto your eye instead of further away, they can be thinner, they don't have to be quite as thick and quite as curved. But for astigmatism, the contact has to have a very specific orientation because it's curved different ways in different directions. So if you look at contacts for astigmatism, you'll notice little markings on them, often indicating where the bottom of them should be. So you can try and put them into your eye in that orientation, or if you just put them in and start blinking for a bit, then they'll naturally settle to the right location because they're made heavier at the bottom. So that's how glasses and contacts work. Laser eye surgery corrects for your vision errors by actually removing parts of your eye. So let's say you're nearsighted, focusing light sooner than you should. So that means you need to have a less powerful cornea, the front of your eye. So the laser in laser eye surgery can flatten it. It can make that cornea less curved, causing it to bend the light less, correcting for nearsightedness. And a similar type of correction can be done in many cases for certain degrees of farsightedness or astigmatism. If you'd like to look into laser eye surgery so that you no longer have to wear glasses or contacts, it's worth talking to your eye doctor about to see if you're a good candidate for it. If there's another eye-related topic you'd like me to talk about, please leave a comment down below, and please subscribe if you found this useful or interesting. Thanks.